Recording in
progress. All right, class, welcome to a Monday. So let's see, 10.1 homework is due this Wednesday. I figured 10.2 is due this Friday. And then we'll kind of work it that way. So then we only have a few days left. So today's the 23rd. I figured 10.4, I'm gonna just kind of push to get it done on the 25th. And then we're doing 10.5. Are we doing 10.5? You guys talk to me on the homework here. Was there 10.5 on the homework?
No.
Oh, gotcha. Okay.
Just go to 10.4.
Just 10.4. Okay, that's even better. Okay. So I'm going to redo the schedule for you guys, and we'll have sort of like the final schedule for the class. I'll give it to you guys on Wednesday. Don't forget, we still have something called algebra presentations.
No. Why?
Then we have the verbal final. And then we have the written final. And so, and because I'm such a gracious teacher, we will forego a chapter 10 test.
Thank you.
So,
I don't know what you just said.
go ahead.
Just this semester.
I don't know. I'll think about it.
I don't
I
remember.
have not decided yet.
Last year's my
No,
very
it's easier to have the whole.
petition.
Uh-huh.
Please not do last semester as well.
Just this semester,
Please gracious sir.
I will think about it.
Like, I don't even remember what we went.
Yeah.
Right, yeah, what happened last year? Okay, so real quick here, I made an executive decision as of now. There's no chapter 10 test. Just don't have time for it. We are still going to do the algebra presentations, still verbal final and a written final that we're deciding upon whether or not we will include last semester or not. So let's jam. So any homework questions on 10.1 or 10.2? Let me do that real quick here, and then we'll jam. Okay. So 10.1 homework questions or 10.2 homework questions? Let's do those. Okay. 55. Okay, any 10.2 homework questions? All right, 10.1, 55. Looks like is the only one here. Do you guys remember this one? Have you done this one yet? It is a, hey, how we actually make roof. A roof, if you've ever been in your attic. Raise your hand if you've ever been in your attic. Okay.
One could be someone else's attic. For 10.1 could you do 21?
Include 10.1. No problem.
Dude, I've been in there a lot. You know, when you get locked out there, it's not really a way to get.
Okay, so we have that. And if you guys ever walked there, let's see, we have a truss that comes down this way. Tell me if you guys have seen this before. And then you have a right angle that comes down because that bears a lot of the roof weight like that. I remember that. Just to go up there a few times here and there. So yes, absolutely. So now the question is this: if for some reason this guy is 3 feet across, or no, sorry, 36 feet across. 36 feet across. This guy is 6 feet high. This is another 6 feet high from here to here. Not drawn to scale at all. We need to figure out what is this angle called alpha and this angle called beta. Do you guys know that? So talk to me. Anybody has figured that one out yet? Maybe not. That is a 55 on 10.1. Abby?
By the two lines intersecting.
The two lines intersecting.
As in the bottom line and the side line. Could we find the corner angle?
Oh, one more little piece of information. Sorry, Abby. So how here to here is 9 feet.
So then, wouldn't it be that the tan y is 6/9?
So this guy here. Let me do that here. Let's see. I'm going to bring this out just a little, make it bigger.
Is it 6 high?
It's 6 high. It's this one right here. That's a right angle there. We're trying to find beta. Perfect. So we know that this is 6 here and this is 9. Okay. All yours. Alka says that's just tangent. Is that right? So if we go like this here, did we study tangent to be the? We just figured that to be the slope. Is that right? That's the inclination of it. We just studied SLOCA. Gotcha. Okay.
Whatever 90 plus, whatever.
Gotcha. Okay, guys, real quick.
48 degrees, 45.
Yeah, that would be 90.
Uh-huh.
Well, they all have 180, so then we know that the two of those need to add up to 90.
Mhm.
So 45.
Let's see, guys. I'm going to stop here because you do need.
Equal, the two angles are not equal because that's a 90, so it can't be 45.
You guys, real quick here for number 55. I just realized you need trigonometry, which we did not do. Okay, unless you read it up yourself here. So I'm going to go like this here. We're going to skip number 55.
Oh,
Good there.
Let's go.
And now if Alec already finished it up. That's cool. You just need to know one little piece of information which will handle, or you guys might have remembered it from geometry. Did you guys do tangent?
No.
No, I just watched a Conic video.
Okay,
Yeah.
okay. Gotcha. Okay, so real quick here, 55 canceled. We good?
Wow, okay, this filter is way too strong these days.
Yeah, please leave it on the we did. Okay, so let's jump to 21 then. 21. So this is 10.1. 21. Find the inclination of this little guy right here. So it's 5x plus 3y is equal to 0. Let's please draw it like we did. So subtract 5x from both sides, divide by 3. And the question is, can you at least draw this as a line? What does that look like? Let's see, there's a 0 at the end. So that means 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, because of this little guy has a little 0 at the end, our dot starts at 0, 0. Right at the origin. You don't have to draw it. There's kind of visualization for you guys here. So 1, 2, 3, 4, 5 down, 1, 2, 3 across. And so I have a line that is going down like this. Question is, what's the angle right there? What is that right here? All right, so notice this. The angle, the slope is negative. So you know you're going to get something higher than 90 degrees. So what we do here, there's two different formulas we use, is that right? If the angle measurement is less than 90 degrees, what we do is we use theta is equal to tangent inverse of the slope. And we're done. Anybody remember what we did for theta is greater than 90 degrees? We just add pi. So tangent of 90 degrees of m plus pi, or technically 180 degrees, just depending if. This one right here? Yeah, it's ang symbol for angles. It's like this little circle with a little 0, and then kind of folds in on itself a little bit. And it is called theta. Cool. All right, so we use this little formula here. So it'll be tangent inverse of a -5/3. Need your calculators here. And then real quick here on the homework, does it give you in degrees, in radians and degrees? Okay, whew. Okay. So let's do that in radians. And we'll do the next one in degrees. So we'll do it twice. So the only change on your calculator, let me go over here. All right, so let's go with it. Those that brought their calculators. You're going to go to mode right over here. And depending what it says, you're going to go down to, we're going to do radians first. So you want to make sure that radians is selected. So check that. And once you've checked that and everything's good, got a few people still taking it out, taking their calculators out, go for it. Okay, once you do that, you got this little quit button right here. So it's gonna be second and then click on mode again. And it should take you back to the home screen. Cool. Okay, so we are in Radian mode. We're gonna go with a tangent inverse. So it's this little tangent with a little -1. Okay. And then we're going to put a negative. So careful in your calculator as well. You have a minus symbol and you have a negative. You have an operation and then you have a negation. So make sure you click -5 divided by 3. And then you can always just add pi already here. So plus and pi is located right here. It's the second of, this is called a caret key. Takes you to the exponents. So 2.11. How many degrees is that? That's about right for, so let's do degrees because it makes a lot more sense because we deal with degrees a lot. By the time you finish trigonometry, you're gonna be very familiar with radian mode. Radian mode, like that's so easy. So let's do this here. Let's go to mode again. Let's come down to radians and then we're using arrow keys, go to degrees and click enter. So you want degrees highlighted.
I still haven't been able to find the calculator.
I am so sorry. That's not cool.
I need to pay practice somewhere.
So we're in school, you think?
I honestly do.
So tangent of -5/3 plus 180 is about 120, 121 degrees. And that looks like about 121 degrees. That's like half of or a third of a full circle there. Okay, everybody good there? So we are literally taking algebra, a line, and we're kind of fusing it with geometry, which is angles. So putting those two together, something we have not done before in Algebra 1 or Algebra 2.
What is the 2.11 do?
Oh, sure. So just a quick aside here, radian measurement. Here's what we got. So it's just another way to do angles. And so if you take, oh, let me do it like this here. If you take any circle, no matter what size the circle is, and you measure its radius, you kind of go like this here, and you say, you know what? That's going to be any circle is going to have a radius of r. So what you do is you just take this amount right here, and you start laying it on top of the circle itself. So that same amount, and it's probably going to go about to about right here. That's your kind of r value you lay out. And then you do another one here. So probably even longer than that. Sorry, that's a little too short even. Ah. There. Okay, about right here. So that's R. So then what you do is you do lay it out again. and you get another R, and then you lay it out again and you get another R. And remember, the bigger the circle, the bigger the radius. So these guys are going to be very standard points where they hit. So you're taking the radius and you're just kind of putting it around the unit circle or around the circle. You go like this and you go like this, and nothing fun happens. 1, 2, 3. So 4. You got 5 about to right here. And then you got 6 is about right here. And then you got this little extra piece. And if you measure the extra piece, it turns out to be about 2.8 of a radius, of the same radius. So then, kind of funny, if you start counting 1, 2, 3, 4, 5, 6, to go all the way around the circle is 6.28 radians. And that number,
That's double pi.
that number is not so much important until you just divide by 2, and then all of a sudden it becomes interesting. So then you say, whoa, hold on. So that means if I do this in terms of pi, if I start multiplying pi to this, let's do this again. Big O circle. We take R. And I'm going to do this here. I'm going to take R and I'm going to multiply pi to it. So if I were to cut a circle in half, like that, the angle measurement to go over here is be pi. Good there. And it doesn't matter. I mean, you just multiply by R, but that's the angle measurement. So then this would be pi over 2. Anybody, we figured out this last time. This was Wednesday, right? What's this guy over here? Anybody? Oh, fun.
Is it like 3/2 pi?
How come, Luke? How come 3/2 pi?
That's the first order is pi divided by 2, and the second one's full ones.
Yeah, this is pi over 2, and this is technically 2 pi over 2, right? And then you're adding a corner, then you're adding a full piece. So 3 pi over 2 is perfect. So all the way around the circle would be 2 pi. We good there? So it is just another way to do angles. So I could just erase all this, and I could put in degree values. So pi divided by 2 technically is 90 degrees. Pi, it really just is 180 degrees. 3 pi over 2 would be 270 degrees because that's just 90 plus 180. Good there? So we have 2 ways to do angle measurements, radian measurement and degree measurement. The radian measurement is by far used the most in mathematics. We hardly ever use degree measurements. Okay, good there? Cool. All right, and did we take care of 21 already? Cool, we're starting then 10.3. Okay, let's jam, 10.3. So last time we covered something called parabolas. You guys talk to me, were parabolas pretty cool? Applications of parabolas pretty cool? That's kind of cool. Satellites are based upon parabolas. That's it right there. The reason why our cell phone works is because of parabolas. Okay, so this one called something called ellipses. They kind of, I don't know, let's see. It's a circle that's been stretched out one way. So it can be a circle that's stretched out this way. That's an ellipse. It's squashed down. Or it's a circle that's squashed the other way. So there's kind of 2 different types of ellipses. It goes like this. Okay, so then what's up with an ellipse? Oh, do you guys remember how like a circle has a center? Right? What happens if you squash a circle, that center, it like splits off into 2 different pieces. And usually one is on one side. I mean, all the time one is on one side. And one is on the other. And you can kind of think of it 2 different ways. You can think of it as just dots inside an oblong circle, or you can think of the face of big here 6. One of the 2. So now we have a focus and then we have another focus. And at the plural of focus, anybody? Foci, all right. So now we have, instead of a focus, which is a parabola, we have foci, 2 of them. So what is the geometry definition of an ellipse? Here it is. Remember how, this is kind of interesting. Remember how on the focus on a parabola was everything bounces into that little focus area, right? This one's kind of weird. It's this one right here. If you were to take, so D1 plus D2 is always constant. So if you take a rope and you take a rope that's, or a string of some sorts, and you make it certain length that's longer than the length from the 2 foci, and start drawing it out, you'll draw out an ellipse all the time. Okay, so then this one's a horizontal ellipse, this one's a vertical ellipse. So big heuristic sleeping. I don't know. No problem. No problem.
How are you about to get there?
You're large, that's pretty good.
No wonder you're always
Yeah,
late.
this
It's a whole bunch. Okay, so now let's do this here. That was the geometry definition. Now let's fuse algebra into it. Stick algebra, what we're gonna do, we're gonna take an axis, X and Y axes, and we're gonna stick an ellipse right onto the axes. So there are foci over here, that's fine, but this guy's called the major axes, and it just means which one's the longest or the longer side. The horizontal up and down coming across. So this one right here, this is going to be the minor axes or axis. There you go. It's the shorter side. All right, and now we have, for this one, we actually have 2 different formulas. We're going to do each one of them here. So here it is, fusion of algebra and geometry. Here's your formula for got these H and K's again in here. And so notice it's going to always be equal to 1. Does it have to be on the origin? It doesn't. We can move it out by H and K. And H and K, all it means is you just move it so many units to the left or right and so many units up and down. Okay, let's do the other one here because we have a horizontal one. Let's do a vertical one. Sure. Half an hour. Do that.
Sorry, the first one, an H or a K.
By X, by the X, that's X minus H. Cool. And then the next one, and then we'll be all good to go here. This one. Tell me if I'm going too fast as well. That's fine too. Boom. So again, that's going to be the major axis for us. That's going to be the minor one now. Okay, good there. We'll get there. We'll get there. Okay. And then one more last thing to add at each slide here. So the foci. Lie on the major axis. C units. I should bring that up here. How fun is that? That's cool. 2 units away from the center. Oh, we forgot to do a formula here. Formula for this one, all that changes is your H. So your B and your A's change. That's K right there. A squared is equal to 1. Okay, so Mr. G, what's going on here? It just means this. The relationship between A and B is going to be that A is the biggest one. So wherever your biggest one is, if it falls underneath the Y value, we have a vertical ellipse. And if the big value is underneath, I usually don't write it that way, not greater than symbol. Usually write it like this here. So there it is. If the bigger A value is the bigger one, if it falls underneath the X, it's a horizontal ellipse. Okay. Are we good there? This one, Noah? Yep. The 0 is less than B, which is less than A. Okay, before going here, let's see ellipses. Where do you see ellipses? Sometimes you see it in architecture when you don't need a exact semicircle. You somehow need to expand it out a little bit further. So let's say this is kind of like a pillar of something, right? And so that's not what I need. I need it bigger here. So then it'll stretch out that way where these guys are still pillars. So there's your sort of ellipse that comes around. Say again, say again. Oh, of course.
You mean the metal one?
Yeah.
Yeah.
The metal.
The metal beam.
No, it is a big metal. It's just the shape. It's like really, really ugly.
Oh, okay, now we're judging.
Okay.
I'm sorry, of all the installations that they could have put into the middle of the square, they just chose.
Oh, wait.
Just out of everything, they were like, yes.
Uh-huh. Let's see, what ellipses are probably most known for is rotation of planets. So you have the sun here, a little sun, and you have some kind of planet here, and it'll kind of go like this.
My algebra presentation.
And then usually you have a foci. The sun is the first foci, and then there's somehow somewhere in space is the second foci of each planet, because planets don't go in exact circular orbit, they go in an elliptical orbit.
History of algebra for a presentation.
Didn't both of us do
Yes.
Uh-huh. And so let's see, anything, the moon does the same, right? There's Earth. Earth is here, and the moon is not exactly circular orbit. It's just off just by a little bit here. So not even that much. I mean, it looks
To the naked eye, you can't tell that it's an elliptical orbit.
correct. Yeah, it's so close, but yeah, it's still not exactly a circular orbit.
The Earth is as well, and then the Earth also is more of an oval than a sphere because it, towards the middle, it's wider than. It's
Very true.
wider because of this thing towards the.
Perfecto. Okay, so let's go 1, 2, 3. Three example. I think we can do that here. So example 1, find the standard form of the, too much English, equation of the ellipse ELIP having, oh cool, okay, so this is the description here, foci at 0, 1 and 4, 1. That's it, that's all we know. That's all we know. So let's see, let's at least graph it. Let's see what happens here.
It's
So,
the horizontal one.
oh, cool. Yeah. So because it's on the 0, 1 and 4, 1, 0, 1, it's right here. There's one guy over here. 1, 2, 3, 4. There's the other guy. So, you know, it's a horizontal. So I have H. So let's see. The equation I'm going to use as I start filling in stuff is H minus 10 over A squared y minus K over B squared is equal to 1. Okay. All right, the H and K are still the center. So notice we, like on a circle, whenever you guys make the center in a circle and then you draw the circle out, that center is not part of a circle. We're good. It's just the outside stuff, right? Even though we always put dots for the center, right? It has nothing, it's not the graph of the circle. Circle is a circle. So same thing here. Well, there is a center for this ellipse, but it's not part of the drawing of the ellipse. We're good. So the question is, what's the center? It has to be, absolutely, because this,
1.
perfect. So this little guy right here, 2, 1 be the center. Hey, and that's cool because that is H and that is K. So we're building this here, x minus 2 to the second power over A squared, y minus 1, the second power over B squared is equal to 1. We just need to find A and B. Yeah, what are A and B? A and B are,
Is it the top and the bottom?
I think that's what it said. Let's see, let's look at our notes here. So, oh, no, it's a subtraction here. So note says C squared is equal to A squared minus B squared. That's one piece. Okay, I'll give you the easy one here. Let's go back. So that's the connection to the foci. We'll need that formula.
C is 2, so that's just 4.
Uh-huh.
Yeah, we already covered that, but then how do we get A squared to B squared? Or we should at least get A or B, and then we can figure it out. So if C is the line on the main, skewed its way from the center, then is A and B also a point on the ellipse or?
Yeah, that's what I'm trying to find. Let's see, because we're missing one piece of information here. Just want to see if I, okay. I didn't write down the whole problem. How about that? That helps. So that's why, like, I'm confused too. So let's finish writing down the problem. So big O period here. So the length of the major axes is 6. So let's go back to fill out a diagram. So let's go back over here. Let's fill in our little pieces here. So this piece from here all the way to here would be 2A. And then here to here would just be 2B.
So minor axis is 2B, major axis equals 2A.
Yes, so let me scoot that up just a little bit here.
We know that A is 6, right? For length of the major is 6, so then A is 3, you said A
Awesome.
squared is 9.
Okay. Let's go back to our problem now here. So let's see. It's 6. So 1, 2, 3. So that means the end of my little ellipse right here, it happens right here, right? There's my little curve. So from the center to the end, that's gonna be 3 units only instead of 6. So I have my A value. A value is 3. That's cool. Say again? Yeah, we could do that too, huh? We can go over here. So that'd be a -1. It's going to curve this way. So I got that. That's cool. What's the C value? Let's go back in our little notes here. What's the C value again? C value is the foci line, the major axis, C units away from the center.
But there isn't one.
The foci, they lie in the major axes and it's C units away from the center. C is 2?
C squared is 4.
No, it was given. I forgot to write it. Oh, because the major axis is 6. So it's 3 and 3.
Major axis is 2.
Okay, I think I'm good here. So C value I know as well. It's the C value. 2. It's the distance from the center to the foci.
So then B squared is 5.
I'll go with that. Let's see.
That doesn't.
Yeah. So let's solve this guy for B. Or is this going to be just 4? This would be 9. Everybody okay there? We're squaring the C, squaring the A value. Subtract 9 from 4 gives you -5, which is negative B. Drop the negatives out, gets me 5. And how about B gets me a square root of 5? Anybody punch in square root of 5 on your calculator? What is that about, approximately? So 2.3. So I'm going to go 1, 2. If I was to go down 2.2. Okay, so 2.2. So about right there. So if I were to draw this ellipse, it would kind of be like this. So 1, 2, and a little bit more. Okay, and it doesn't tell us to draw it. It just tells us to give the equation for it here. So I'm going to just do this here. I'm going to plug it in. This guy, A value is 9 here, and the B squared value is
5.
and we have our equation of our ellipse. Now, planetary motion, slightly more complicated. Yeah, just a tiny bit more complicated. Okay. So let's do two things here, which is going to be on the homework here. So first things first, let's sketch an ellipse. And then let's find all the different pieces of an ellipse. So exercise 2. Sketch the ellipse. And here's my equation. H. Now this is what? This is the generic equation for conic sections, right? Just real quick here, those that were absent last week. We learned that this guy can give you all the different conic sections whatsoever. It is the most generic formula. Do we have an E at the end? Let me just look back to 2.10. There's an E there. Just to catch up on a few people. Yeah. So A, B. Oh, yeah, we forgot the X, Y. Sorry, let me go back up. There's X squared. The equation in the book, I just want to give it to you exactly the same way they have it here. So it's BXY plus CY squared plus DX plus EY plus F equals 0. So people that were not here last week, look at this. This is such a generic equation. It covers everything that you've ever done in algebra.
Fun.
And it says this: if you were to solve this equation like 2x plus 5 equals 0. That was like the first things we ever solved in algebra. Notice it's kind of like all this is gone and this is gone. And you're kind of just solving dx plus f equals 0. If you're to say, you know what, we got sophisticated. I remember not just that, I remember solving for or graphing. How about 2x plus 5y is equal to 7? I remember graphing that, but that's easy. That's just that right there, right, with the f turned to the other side. And then I remember graphing parabolas. I remember graphing something like x squared. Well, that guy. Well, that's good. That's just all of this gone now. And you're left with x squared. So that is the generic equation for algebra. Now what we have here is the way it fits out with the x squared and the y squareds and the way things are set up. This is going to be an ellipse. And so with it, let's go for it. A little bit of work ahead of us, but that's okay. So first things first, we're going to do this. We're going to get our x squareds together and our x's together. And we're going to leave a little bit of space and put them inside a little parenthesis. And then we're going to move the 4y squared over here, minus 8y, put them in a little parenthesis, and then move the 9 all the way to the other side. And then you guys remember doing completing the square? Now it's an Algebra 1 skill, completing the square. Did we do it in this class? We should have done it at least a few times. Yeah, so what we do is we take, oh, that's right, exactly. We take the middle term divided by 2. And what we do is we square it, and this will give us a perfect square trinomial each and every single time. So if this is a plus 9, this guy becomes x plus 3. It's just the exact same number before you square it, because remember at the end, it's always the last term times the last term. It gets you the 9, where those are the 3s that give you that. Okay, it's squared. Okay, guys, real quick here. If we were to add, we're adding 9 on one side, we have to add 9 on the other. Boom, there's that. Next, ooh, I don't like this one here. I don't like the 4 in front of y squared. So we're gonna do a little bit more work. Not so much divide by 4, but actually factor out the 4. So now we're left with this guy inside this little parenthesis. Okay. We are going to take the -2 this time. Divide that by 2. Get ourselves a -1. We square it. We add 1 into here. What do we subtract on the other side? I love it when someone says it because I can say like wrong or eh. Add 1 eh. Do nothing eh.
Do something, subtract 4.
Subtract 4
Divide by
or add 4.
Yes.
do something.
We're gonna do something with 4. We're gonna add 4
Okay, that's cool.
because whatever we added to one side, we added. How come it's 4?
Yeah.
So technically, you're adding 1 inside the parenthesis, but you're actually adding 4 to the whole entire side because of the multiplier. Okay, I got this. I got this. I got myself a. Oh, the 4 still on the outside, huh? So 4 on the outside, and this is y minus 1. Everybody agreed here? Squared equal to how much? To 4. Okay, notice the 2 ellipse equations, they were always equal to 1 for us. So all we're gonna do here, just gonna divide everything by 4, because this little guy right here. Divide that by 4, that by 4, that by 4. And we get ourselves x plus 3 to the 2nd power divided by 4. This would be y minus 1. Now to put it into the same exact formula as an ellipse, we're gonna stick a little 1 there. Ooh, I can actually even ask some questions here. All right, questions of you guys here. What is my center of this ellipse? Let's actually, yeah, let's combine these two. Center.
-1.
I love it. And
-3.
yes, perfect. -3, 1, because the formula itself has a negative inside there, right? It's at x minus h, x, y minus k. So always reverse the symbols here. Okay, so there's that. Give me, what's my a value? 2 is perfect. Is it 2? 2, yeah. What's my b value? 1. Let's see. Oh, cool. How about my c value?
Square root of 5.
So C squared equals A squared. Plus A squared is
Oh, it reminds me,
A
so
squared
it's
minus
square root of 3.
Square root 3. Okay. Okay, guys. Based upon that information, can we graph our ellipse here?
Oh,
Can we
absolutely.
sketch our ellipse? Oh yeah, this formula for the formula is a squared minus b squared. So then it becomes 4 minus 1 minus square root. Okay, anybody real quick on a calculator, give me to the nearest tenth. What's the square root of 3? Square root of 3 is roughly. Okay, I'll keep that in mind. Okay, so -3, 1 is our center. So let's graph it here with time remaining. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so let's see how we can put this together here. So 1, 2, 3, 3, 1. Here's my center. This is my A. A is 2, so 1, 2. So this is the end of my. Whoa, hello, come on. That's kind of the end of my ellipse on this side at -1, 1. There's the end of my ellipse over here at 5, 1. Oh, that's so cool. So then this guy goes up and down by 1, is that right? No, by half or by 1? By 1, okay. So that means this guy, oh, that's so cool. So this ellipse just nicely touches -3, 1, -3, 0, sorry. And 4, 1. Okay, so let me, now that I have the kind of the outside sort of set up here, let me graph that guy. Cool. All right, then I just need to put my, with 1 minute and 10 seconds left, I need to figure out what this was about 1.7-ish, is that right? 1.7, so it's 1.7 away from, in fact, I'll put them in red here. So 1.7, about maybe like right there. And 1.7 about right there. Okay, now, you guys ready? Can you label all these little pieces?
And then on the left is D1, right? The red.
So I'm gonna just like kind of label like this piece here. I guess you don't have to do it on the homework here. As long as you kind of have the same structure here. Yeah, maybe just the foci here. What would that be? I know, like what's the
Oh, the number.
the number? -1.3-ish. Yeah, 1, okay, and then this one. Let's see how much they make you. Okay. Okay, awesome. I just want to see how much they make you label. So yeah, they want the center and foci. Okay. And that is it. Done. A minute behind schedule. So. All right, those of you that were not here last week, I do have the YouTube videos posted, but I just never sent you guys a link for them, so I will do that. And if you don't get a link for me by end of today, email me again and I'll. But so.